Jai Hind, dear students. I am Dr. Preeti and here back with the third lecture of carbons compound. This will be our last class for carbons compound. So in this chapter, in this portion of the class, we are going to study about ethanol, ethanoic acid, soaps and detergent. If you like the videos, please like, share and subscribe. So here we start with ethanol. Ethanol is C2H5OH. It is the second member of the alcohol series. We have seen that yesterday. And ethanol is also used for drinking purpose. The alcohol that is used for drinking purpose is ethanol. But ethanol, not only for drinking purpose, it's a very good solvent also. It is used in cough syrup, paint industry, and in many industries. In tincture iodine also ethanol is there. So it's a very good solvent, and so it has various applications. But it could be misused also because it's for drinking purpose also and a solvent also. So if in industries it is brought for some industrial use, there has to be a way to prevent it misuse. And how it is done? By adding a small amount of methanol to it. Methanol, even in a very small amount, that is highly poisonous. So what is done? A small quantity of methanol is added to ethanol to make it unfit for drinking purpose. But to make it clear to the people that it is not for drinking purpose, a small amount of dye is also added to it. So, such an alcohol in which this dye and methanol are added, that is known as denatured alcohol. So, what is denatured alcohol can come as a 1 marks question. Next is absolute alcohol. 100% pure alcohol is known as absolute alcohol. So, you should remember that. But this 100% pure alcohol is never used for drinking purpose. For drinking purpose, always some proportion of water is mixed with alcohol. If it's 100% pure alcohol, that is absolute alcohol, that is lethal. Lethal means it can cause death of a person if consumed. Okay, so that is about alcohol. One last thing is that it is also a very good fuel, because yesterday also we have seen the combustion reaction of alcohol and produces carbon dioxide and water, and it is not going to produce any other thing like sulfur oxides or nitrogen oxides. So that is why it is a very good fuel also. Recently you must have read in the newspaper also that we have made some cars that will be using ethanol as a fuel. So it's a very good as a fuel also. It's a cleaner fuel. Next we have to see about the chemical properties of alcohol. So let's see that ethanol, when it is going to react with sodium, which is a metal, then ethanol is going to react with it. Hydrogen being less reactive than sodium, sodium is going to replace this hydrogen and we'll get C2H5ONA, and hydrogen gas will be liberated out. Hydrogen gas is liberated out. How you can test that hydrogen gas is liberated out? Because if you bring a burning candle next to it, it will burn off with a pop sound. So by that way you can identify that hydrogen gas is formed. But this hydrogen was formed in one more reaction. Do you remember that? When metals reacts with any acid, then also hydrogen gas is formed. So if someone asks you, examiner asks you, then one substance X is there that when reacts with sodium, a gas is released that comes out with a pop sound. That substance could be an acid, it could be ethanol also. Okay, so just keep that in mind. Okay, next is this ethanol. I'm going to just write it bold because I'm in this only we are going to show all the reactions of ethanol. So this ethanol, when it reacts with concentrated sulfuric acid, concentrated sulfuric acid is a dehydrating agent. Dehydrating agent means which can remove water from something. So concentrated sulfuric acid being a dehydrating agent, it will remove water from this alcohol, and what will be there? OH is removed, one H is removed. HOH is water. है ना? So what will be remaining? C2H4, that is ethene. we will get alkene, that is ethene, plus water will be removed, because always remember that concentrated sulfuric acid is a dehydrating agent. So it will remove water from alcohol and will get ethene. Next is alcohol. Yesterday we have seen one more reaction. I am adding up here only, that when this ethanol reacts with alkaline potassium permanganate or acidified potassium dichromate, then it is going to produce carboxylic acid. Okay, so these are the reactions of alcohol. All the three are important. This is oxidation reaction. What will happen when alcohol reacts with oxidizing agents like potassium permanganate and acidified potassium dichromate? What will happen when alcohol reacts with sodium or any metal? What will happen when ethanol reacts with concentrated sulfuric acid? I'll just shift to side and you please just take a screenshot, because it's very useful for you all. So I hope you have taken the screenshot. Now we'll see about ethanoic acid, and we'll see also what happens when ethanol and ethanoic acid react with each other. Okay, so let's see about ethanoic acid. Ethanoic acid is belonging to the carboxylic acid group. Its formula is CH3COOH, that is ethanoic acid. Its common name is acetic acid. One more thing is there, you must have heard about vinegar. Vinegar is having acetic acid. So 5 to 8% of vinegar is added to water. 5 to 8% of pure ethanol, pure ethanoic acid is added to water, and that only forms vinegar. So vinegar में क्या है? 5 to 8% of ethanoic acid and rest all is water. Okay, that is vinegar. Apart from that, pure ethanoic acid, it has a freezing point of approximately 290 Kelvin. It's somewhere around 17 degrees Celsius. Why I'm telling in degrees Celsius, easy for us to relate the things. So in winter season, this pure acetic acid freezes, freeze हो जाता है, because freezing point is just 290 Kelvin. 17 degrees Celsius is easily reached up during winter season, and it freezes and it looks like a glacier. So it is also known as glacial acetic acid. One more name of acetic acid is glacial acetic acid, as it freezes during the winter season. Okay. Now let's see about the chemical properties of ethanoic acid. One very important property related to ethanoic acid is esterification reaction. So we'll start with that, esterification reaction. In esterification, what is there? We take ethanol, C2H5OH, and we make it to react with ethanoic acid in presence of an acid. Okay. Now, if you remember, acids, I told you that they are a dehydrating agent that can remove water from it. So, in from this also, what will be there? Water will be removed. Okay. So, what we will be left with? CH3, COO, and here C2H5. If you want to write a structure of it, it will be CH3, COO, CH2, CH3. Okay, so this is ethyl ethanoate. Its name is ethyl ethanoate and it's known as ester. This is an ester. And esters are very important compounds because esters are the flavoring agents. So esters like in strawberry flavor or artificial flavors, whatever we eat, that is because of some esters. They have a very peculiar sweet smelling taste. So sweet smell. So they are known as esters. They are used as flavoring agents. So what we do, we mix ethanol not having a good smell with ethanoic acid again not having a pleasant smell, and we get ester that is having a very sweet and very nice smell. Okay, very nice fragrance is there. So दो बदबू वाली चीजों को मिलाने से हमें रूम में खुशबू ही खुशबू हो गई. By that you can remember. Ethanol plus ethanoic acid, we get ester and water will be removed. Okay, and that to remove water only we use the acid, because acids work as a dehydrating agent. Now this, in this reaction ester is formed, so this reaction is also known as esterification reaction. Okay, now we'll see what, how we can use this ester. Using this ester we are going to form a soap. So the next reaction that we'll see is saponification reaction. What is saponification reaction? We are going to use the ester that we have formed. What was the ester? Ethyl ethanoate, CH3COO, C2H5, ethyl ethanoate. That was our ester. We make it to react with any base. It could be sodium hydroxide or it could be potassium hydroxide. We make it to react with that. So what will happen in this reaction? C2H5 and OH will be removed. What is C2H5OH? Alcohol. है ना. फर्स्ट स्टेप में हमने यूज किया था अल्कोहल को एस्टर बनाने के लिए, एंड सेकेंड स्टेप में हमने उसको जब सोडियम हाइड्रोक्साइड के साथ रिएक्ट करवाया, वी अगेन गेट बैक अल्कोहल. सच अ थिंग कि जो हम रिएक्शन के फर्स्ट स्टेप में यूज करें और सेकेंड स्टेप में हमें वापस मिल जाए, एट द एंड ऑफ रिएक्शन वी गेट इट बैक. Such a compound is known as a reagent, not mentioned in your book, but it's called a reagent. So apart from that, what we will be getting? CH3COONA. Okay, sodium acetate, that is also known as sodium acetate. We will be getting that, and this is only the structure of a soap. So we call this reaction as a saponification reaction. Fine. Now next two reactions of ethanoic acid are very easy to very easy and very simple to memorize. But how they come as a question in your exam? You could be asked in your exam that experimentally how will you differentiate between ethanoic acid and ethanol? So how you can do that? If we take ethanoic acid and we make it to react with sodium carbonate or sodium bicarbonate. What is sodium bicarbonate? Baking soda, that is there at your home also, na? If we make it to react with sodium carbonate or sodium bicarbonate, then what will be formed is, in both the reactions the product is the same, CH3COONA, sodium acetate plus water plus carbon dioxide gas will be liberated out. Now this is very important. Since carbon dioxide gas will be liberated out, we can find it out by passing the gas through lime water, and that lime water will turn milky. So by that way we can differentiate between alcohol and acetic acid. If we use alcohol in this reaction and we try to make it, it's NaHCO3. It's sodium carbonate or sodium bicarbonate, that is NaHCO3. So in both the reactions the product will be the same, that is we will get sodium acetate, water and carbon dioxide gas will be liberated out. That could be easily tested by passing through lime water, that will turn milky. But if we make it to react with ethanol, there will be no such reaction. Ethanol is not going to react either with sodium carbonate or sodium bicarbonate. Okay, one thing, can you guess why ethanoic acid reacts with these salts, sodium carbonate and sodium bicarbonate? Pause the video and think, है ना? Because these two are basic salts, and since they are basic salt, they are going to react with an acid. Again, it's carboxylic acid, CH3COOH, that is going to react with sodium carbonate and sodium bicarbonate. Okay. So again and again I've made the mistake second time, please excuse me for that. Sodium, then ethanoic acid reacts with sodium carbonate or sodium bicarbonate, sodium acetate is produced, water is there and carbon dioxide gas is escaping out. But the reaction is not so with ethanol. Ethanol is not going to react with baking soda or sodium carbonate. Okay, so by this reaction we can differentiate between ethanol and ethanoic acid experimentally. Okay, physically we can even test it with the litmus paper. Now, next and last topic is soaps and detergents. I feel that you can have soap and detergent, difference between soap and detergent in your exam this time. So just let's learn about soap and detergent. What are soaps? Soaps are sodium salts of long chain carboxylic acid. Okay, so what is a long chain carboxylic acid? Earlier we have seen that CH3COONA was formed, and that was a saponification reaction. This reaction in which CH3CONA was formed, that we called it as saponification reaction, because this is the formula of soap I told you. So in soaps, practically just one carbon atom is not there. It is a long chain of carbon that is there. Long hydrocarbon chain is there. And at the end of the hydrocarbon chain, what we have? COONA. So how will we define soap? Soaps are sodium salts of long chain carboxylic acid. Now, this sodium part is polar in nature. This is known as the head part of soap, and it is polar in nature because sodium is having a positive charge. So, it is polar in nature, and water is also polar in nature. Water is H plus and OH minus. So, water is also polar, and this head part of the soap is also polar in nature. And this hydrocarbon chain is known as the tail part of the soap. So soap is having two parts, tail part and the head part. Tail part is not polar, head part is polar. Being polar in nature, it get attracted towards water, and so it is also known as hydrophilic part. Hydrophilic part of soap. This N, the carboxylic acid chain, that is the hydrocarbon chain, that is not polar in nature, so it doesn't get attracted towards water. So it is hydrophobic in nature. In fact, it doesn't likes water. It tries to be away from water. So it's known as hydrophobic part, hydrophobic tail, and the head part is hydrophilic in nature. Now, what happens when we mix soap? When we put soap in water, the soap molecules try to arrange themselves in such a way that all the tail part is outside the water and all the head part, hydrophilic part, is towards water. But when we mix soap in water, then their soap molecules aggregate themselves in a peculiar manner and they form micelles. What is a micelle? In this, all the hydrophobic tail part is towards the center of the spherical structure, and all the head part are towards the periphery of a spherical structure. So they arrange themselves in such a way that the all the hydrophobic part tries to remain away from wet water by getting aggregated together. So such a structure is known as micelle, and that is formed by a soap molecules. Soap molecules arrange themselves in such a way. Okay, this is all the sodium part, the hydrophilic part. Now, what happens that the dirt, dust, grease present on our soap, on our fabric, that only makes it dirty, and that is also hydrophobic. Oil को भी पसंद नहीं है पानी. You must have observed that. So the grease particles and all, they are also hydrophobic. The tail part is also hydrophobic, but they have affinity towards each other. They will be attracted towards each other. है ना, दुश्मन का दुश्मन दोस्त होता है. So both have like phobia of water, so they are good friends. They will be attracted towards each other. So what will be there? Whatever dust, dirt particles, grease particles are present on our fabric, that will be forming the bond with the hydrocarbon tail. And now what will be there? Our cloth was having that grease that is forming a bond between with the soap molecules. Now what will happen when we agitate our cloth? Very important. You could be asked that why is it important to agitate or beat the clothes or just mix it in the washing machine? So what is the importance of that? So when we agitate our clothes or when we beat it with something, then what happens? The bond between that grease particles and the fabric is broken off. And now the soap molecule is only surrounding those grease molecules. So the soap molecules will be carrying those grease particles. Now comes the third step, that when we mix, we have to rinse our fabric with water, because all the grease molecules are there in the soap molecules. Now those soap molecules along with that grease has to be removed. So what we do next, we rinse our fabric with water. Now when we rinse it with water, then the hydrophilic part having affinity towards water will move towards water, and that will be carried away along with water and removed from our fabric. So this is how the soap cleans our cloth. Okay. So by that way we have completed the cleaning action of soap. The last topic is about detergent. These soaps can work well only in soft water, but if the water is hard, means if the water is having some minerals like calcium ions or magnesium salts are there, then soap is not able to work well in that, because the sodium is there in soap molecules. Sodium or potassium ions are there, and they are not able to work well in presence of calcium and magnesium ions. So what happens, that the soap is able to work in soft water but not in hard water. Now what can we do? Instead of using a soap, we can use a detergent. Detergents can work very well even in hard water. How they are able to work with well in detergents are able to work with hard water? Because as we know that soaps are sodium salts of long chain carboxylic acid. There is not a single chain, that is a lot chain of carboxylic acid present in a soap. The long chain carboxylic acid there is in soap. So we define soap as sodium salts of long chain carboxylic acid, but detergents are ammonium or sulfonates of long chain carboxylic acid. So ammonium or sulfonates are not going to be affected by magnesium or calcium present in water, and so they can work well even with hard water. Okay, so that is the first difference. That is the definition. Second difference is work well with hard as well as soft water, that is detergent, and works well only with soft water, that is soap. One more difference is there that's not mentioned in the book, that is soaps are biodegradable and detergents are non biodegradable, so they are not good for environment. Okay, so that is all about soaps and detergents. Here we have completed with the entire chapter carbon and its compound. Just revise it very well, it's very important chapter, and revise it so well that you get all the 7 marks in your exam. Okay, so that's all for today. Good day.